Hi, Vectors is a set 4 E.Maths topic and a lot of students find this topic a little challenging. So today I pick a question from O-Level E.Maths 2017 Paper 2 Question 6 to take a further look at the topic of vectors. First of all, let's have a look at the question. ABCD is a parallelogram. So we have here ABCD. AB is equals to 2P and BC is equals to 3Q. R is the point on AD such that AR to RD is 2:1. So we have here 2 parts to 1 part. Alright, part A. Express RC as simply as possible in terms of P and Q. So the question wants us to look for RC. We can actually use the addition of vectors to solve for this vector. We can have a look at this. RC is actually equals to RD plus DC. So now the first part is actually to solve for RD. RD is part of AD. And since the question mentioned that ABCD is a parallelogram, AD is parallel to BC. And AD will also be equals to BC. Therefore, AD is equals to 3Q. Since the question mentioned that AR to RD is 2:1, therefore we can actually take RD to be equals to 1 out of 3 parts. So 1/3 multiplied by 3Q, which gives us 1Q. Alright, next part we need to solve for DC. DC is actually parallel to AB. And therefore, we can also say that DC is equals to AB, which is 2P. Alright, so now RC is equals to RD, which is Q, plus DC, which is 2P. And here we have the answer for RC, Q plus 2P. Alright, for part B, we have S is the point of AD, so we have S somewhere in the middle of AD. And T is the point on CD, so we have T somewhere in the middle of CD. Such that RC is equal to 2ST. First of all, we can actually see that the vector RC forms a triangle, RCD. And based on the understanding of similar triangles, we can have S right in the middle of RD, and we can have T right in the middle of CD, so that it forms a parallel line like this. And in this case, we can have RC equals to 2ST. Part 1 is asking to show that triangles RCD and STD are similar. So we have triangle RCD and STD being similar. Give a reason for each of the statement you make. It's easy for us here to use the AA similarity. So by proving 2 pairs of similar triangles, we can prove that these 2 triangles are similar. The first pair of angles we can use is this and this. So angle CRD is equals to angle TSD. And the reason why these 2 angles are the same is because of corresponding angle. Alright, and the other pair will be here and here. So we have angle RCD equals to angle STD. And the reason is also the same, corresponding angle. So from here we can see that a pair of parallel lines it's usually very easy for us to establish two equal pairs of angles. And so here we can say that triangle RCD is similar to triangle STD based on AA similarity. Alright, now for B part 2, we have the question asking for find the ratio area of triangle STD is to area of parallelogram ABCD. First, let us consider the area ratio of the triangle that we have first established that is similar. Area of triangle STD to area of triangle RCD. Alright, so area triangle STD, area of triangle RCD. As we have mentioned that it's actually a similar triangle, considering the fact that this RS is the same distance as SD, their length ratio can be used to find the area ratio. So we need to put a square right here, and that will be equals to 1 over 2 square, and therefore we have the area ratio being 1/4. Alright, let us next consider that BC is 3 cube while RD is 1 cube. So essentially we have this divided into 3 equal portions of parallelograms, as RCD being a triangle that is half of this parallelogram. Alright, so if let's say we are trying to set up a relationship between area of triangle RCD to the area of the parallelogram ABCD, then we can see that this triangle is actually half of this parallelogram, and we have 3 of this parallelogram. So that will make 1 is to 1, 2, 3, 4, 5, 6. 1 over 6. Alright? So if we want to answer the question of area of triangle STD to area of the parallelogram ABCD, that will be equals to 1 over 6 times 4. Alright, so that will be equals to 1 over 24. Alright, now for part 3. Q is a point on BC, so we have Q is a point on BC right here, and triangle QAB is congruent to triangle RCD. So we have RCD here, and we have Q somewhere on BC such that it's the same. You realize that R is actually 1/3 of this AD. So we must have Q also positioned in the 1/3 area of BC. So Q will be right here. And QAB will be like that. Alright, so you realize that these two triangles actually looks the same, just that it's being flipped around. Okay? So now the question is asking, find QR as simply as possible in terms of P and Q. So let's have a look at where QR is. QR is gonna be here. QR. Alright? So similarly as the part 1, we know that vectors can be defined by the additions of other vectors. We can actually utilize the addition of QC plus CR to help us find QR. Alright, so what is QC? QC is actually the same situation as what we have here in AD. So this is actually 1:2. Alright, QC is actually then equals to 2/3 of BC. 2/3 BC will be 3Q as we have previously mentioned in the question. So that will give us 2Q. Alright, next we need to find CR. CR is just the opposite of RC, so it will be the negative of RC. Okay? CR will be equals to negative RC. So we have minus Q plus 2P. Therefore, we have a minus Q minus 2P. Okay, now we are ready to input into QR. QR will be equals to QC, which is 2Q minus Q minus 2P. Okay, so this will give us 2Q minus Q will give us 1Q minus 2P. Alright, so this will be the answer for QR.